Welcome. I am John Ramirez. I go by Xeon on the forums. Today in Xeon's 3D lab, animating sprite sheets in Blender and Verge3D. This tutorial is broken into chapters with time codes listed below. In Chapter 1, we will go over creating the files for a sprite sheet and creating a grid texture in a photo editor. Chapter 2, we'll get into Blender and Verge3D. We will create sprite shader nodes for the fire material and go over methods for animating sprite sheets. So let's go! If you search Sprite Sheets, you will find walk cycles and icon sheets with different resolution and aspect ratios that really don't help us understand how to use them. If you've been on the Verge3D forums, you will find references to the industrial robot demo as the standard example of how to use sprite sheets, and that can be confusing too. So let's take a moment, dive into the industrial robot, and see what's going on. Open that thing, get it up, find the sparkles, isolate it. Let's go ahead and get into the shader editor as well. Let me pull up a window. Shader editor, there we go, and take a look. And you're going to find that it's controlled by two values, and the values are going out of bounds, and that's a problem. Just because it doesn't seem like it's actually using the entire sprite sheet, so I'll throw a grid on it of numbers. We'll get in there and take a look, and sure enough, for whatever reason, the sequence is not following the sprite sheet. It's kind of randomly going, and this could be a choice of the artist or whatnot, but if we wanted to make this march down the actual sprite sheet, we actually need an increment of 0.125. I would help if I put that in correctly. So frame 2 would be 0.25, or frame 3 would be 0.25, and frame 4 would be, let me see, if we're going to say 1, 2, is that right? Hey, see, this is why I don't like doing this method, but this is a method they chose, so this is what we're trying to figure out and why. So this should be 4 times 0.125. Let's see if that's right. Or 0.625? No, 125 times 4. Let's try that. That's 0.5, so I don't think that's right. So it should be less than that. If you're like me, this is a pain in the butt, so this is why, again, we're going to create this particular video. 0.125 times 3, that's the right number, and we could continue doing this over and over again, scrubbing through, and you'll see the actual frames being counted at the top. To help us create an easier way, we have to take a step back and consider the texture aspect ratio and size. Since WebGL 2.0 is not active by default in many devices and browsers, I still use the WebGL 1.0 standard. This will also make selecting a resolution using the power of 2. For this example, I'm going to use 4096 by 4096. Then it's time to choose the size of our grid. With only 30 frames, I did the basic math. 5 times 5, 25, too few, 6 times 6, 36. That should be good. To determine the size of each cell or grid square, I have to divide 4096 by 6. That comes out to 682.66666 forever. Because I can't create an image with that resolution, I decided to round down to 682. Little did I know that this was going to be a bad idea. Jumping into some nerdy technical stuff, what you see is a 4096 image divided into a 6 by 6 grid using 682 pixels for a total of 30 frames. The pink areas along the right and bottom edge will not be used and can be used for other textures in the scene. Doing some math, we find the right edge is about 4 pixels wide. When we map this image in Blender, we don't initially see a problem until we sequence through the cells and get to cells on the right edge or the bottom row. We find that for some reason, the pink is intruding into the cell, and of course, this is not what we want. Although our texture is 4096 by 4096, Blender's UV texture space is 0 to 1. This translates my 682 cell size to 0.165039066, etc., and exceeds 7 places, which apparently is the rule. So doing some tests, we quickly determine why the power of 2 is so important. Only power of 2 image sizes will generate both a matching cell size as a whole number, but also produce a UV mapping cell size as precision less than 7. Given this, we can quickly create a table of resolution to grid size based on the power of 2 to determine the grid count and cell size. In this example, our cell size will be 512 by 512 with a grid of 8 by 8 yielding 64 individual cells. Okay, enough of the nerdiness. Okay, we're in Apple Motion. We're going to do a 512 by 512 square. We're going to go ahead and get our campfire, basically a particle, and we are going to create some fire here. We're just going to adjust this so the scale is actually fitting the entire 512 by 512 canvas. And we'll go ahead and make some adjustments here to the scale, get it positioned just so. And you can see it's animating just fine. We'll output this as a series of TIFF images. I've done this before, you can tell. So we'll get this unique. We'll go ahead and close that one too. Open up the new file so we can rename them. Let me see if I can get this straightened out. Here we go. Select, change the name. We're done there. Okay, we're in Affinity Photo, but you can use any photo editor you have. We're going to create a texture as 4096 by 4096. It's 16-bit transparent background. I am not going to use an add-on from Blender to do this, but you're more than welcome to do so. I wanted to do this by hand because it's important you understand that the images that we put in here have to be in order. So that's number one and number two, and we keep doing this in sequence so that we go across a complete row. And in a photo editor, I can keep track of the frames in the right order, and I'm going to speed this up so you don't have to watch me go super slow. And now that we're all done, be sure to export it as a PNG for Verge, a TIFF, or target anything with an alpha for Blender. Just remember all the unused space can be used. Now we're in chapter 2, and we're going to go over creating a sprite material, keyframing, and puzzles. Okay, in Blender, remove the default cube, add a new plane, rotate along the y-axis. Let's get set up and go and rename the material, and we'll name it a fire sprite. We'll delete our principled BSDF, and we'll add an image texture node just to start with. And we'll choose our grid so we can see how things look right away. Oh, we need to rotate that along the X by 90. And now we're going to add a mix shader node. And to the mix shader node, we'll need to add a diffuse shader. There we go. And also a transparent shader, because fire is transparent. And we'll set that up, get that linked in, color to color, alpha out of the factor. And we'll go ahead now and create an input. We need a mapping node. Helps mapping node, there we go. And vector to vector. And of course, we'll need a coordinate texture node and UV to vector. And from there, obviously we need to combine X, Y, Z and connect those to the location and to scale. So we can use the X and Y values and place 0.125 or 1/8 into it. We can also create a math node and do a 1 divided by 8, so we don't have to worry about what the decimal values are. And we can see that that is working, but we'll clear these out to make sure that there's no remnants. Go ahead there, connect to there. We got 1/8 in there now. So now we're going to do the next part of this, which is get our ability to scroll up and down. And so I'll do another math node there. Get those over the X and Y, and you can see that we are scrolling through the grid. And I'll put it up in the image editor, and you can see that we're scrolling horizontally, and the other one is going to scroll vertically. But let's set those back to default numbers that we recognize, 0, 0. And this time we need to add another math node because you can actually get this current version to slide to a fraction, and by placing this math node here as a floor, we actually can make sure that we're only moving it by pure integer values and not having any decimals. So if I roll this over for the rows and columns, you can see that they're working properly and not showing a partial cell. So we'll go ahead and make a group out of all this, and then we're going to add some input nodes to our group. The first one will be cell column number, num. Let's do num. Let's add some spaces in there to make it look pretty. Add another one. Let's do cell row num. And one more, which will be grid size n by n equals, so I don't forget what I'm doing. And now we can, where all the grid sizes are, that's the 8 that we're using. We just drop those connections in. And then for the row, we connect that up. But let's go clear these out. I should have done that for the grids, but I'm just going to go ahead and connect it, and I'm sure it'll work. After all this, you're looking at it and go, where did the numbers go? You got to put in the grid size. In this case, it was 8, and everything will look good. You can adjust the individual cells and rows, and you'll see the numbers are working out well. So they are matching the values that are in the upper left-hand corner of the sprite. At this point, you could animate these by keyframing them for Blender, or you could use a driver to do it. There are also ways that you can use drivers in Verge, but we're not going to get into that today. So today we're going to use values. So we'll add some value nodes here. Let's go and get a value. Connect our value to our cell column number, and then we will get another value, and we'll connect that to the row number. And I don't really need this one, so let's skip that. So now we're at a point where if you enter the values in here, that will work. You can keyframe these and create an animation at that point by sequencing through. So let's give these some actual value names that can be recognizable in Verge. So that's the first thing. Otherwise, we'll have two properties in value and value, and that's never fun. So let's call this one column value. That works. Let's give it the same name. And wait a minute, there's something wrong here. I did that wrong. All right, row value and row value. Value, not valve. Okay, there we go. And that one's got to go back to column value, and we are set. Come on, value. Fingers don't want to work tonight. Okay, so as you can see, we scroll through it. Everything seems to be working just fine, and we're in good shape. So at this point, we're ready to begin some lovely animation. Let's go ahead and roll this back to 0. Okay, I'm going to save this out as a blend file so I have it for later use. Also, you can save it out as part of your asset library if you choose to do that as well. Press save. Apply our 3D scene. So this is how we do it for Blender. We have a 3D scene. It has our fireplace in it. Got a texture there, and what we're going to do is drop in the sprites that we're going to use. So we're going to create a plane, get it in here, mesh plane. Let's rotate the Y, and then we're going to pin that material we just created. Now again, that material has the textures of the number grid, but that's fine. We can always change it once we're in here. So we're going to get some numbers here, and we can see it's not rotated properly. There you go, gets it rotated, and we can see that we're sequencing through them as we expected to. So all's good there. So now we need to say, we can change the grid to a fire texture that we outputted earlier. Not that one. Where is it? It's up, sprites. No, there he is. And we use that. And let's position this, just generally speaking, where it goes. Let's increase it, scale it, get it kind of where we want it. And somewhere in there. That looks good. Change alpha to blend so it looks more transparent. No shadows because we're going to have a couple of these and don't want the shadows, the flames to get screwed up. So we'll add a couple more objects to give it some depth, but it's the exact same map. We'll push this one to the back, get it in there. We'll rotate it on Z, and then we're going to add 2 more. We'll just duplicate it, scale it, and let's see, scale this one down. Let's get it over here to the, make sure it's in the middle. There we go. Go somewhere in the middle. That's good. And then we're going to scale it down. I want to just kind of give a little bit of flare to the left side. Just to add a little bit, and we'll duplicate it over to the right side. And then we'll sequence that, and we can got a nice little fire going. That's just going through the first 6 cells, or 8 cells. And then we now just need to go in and pull up the project timeline, and we can animate these through keyframing directly. Now this will work in Blender if you're just exporting through Eevee or Cycles. You just do insert keyframe, first one, go to frame 1, and as we march down the thing, it's column 1. How else if I insert to place the keyframe? Oh, wait a minute, I'm not looking at the right thing. There we go. Insert keyframe 2, 3. I'm on frame 3. So okay, 1, 2, 3. And here this is the 4, 5. So much easier. 6, because I'm on frame 6. 7, I'm on frame 7. I'm going to change rows now. 6. Now, I personally like doing this with the, not with a thing like Fire. I like to do it with the actual grid. So, because I definitely don't have a chance of losing what frame I'm on. But in this case, it's 8. And so that's 0 column value. Helps if I go here, show you the editor. And such a pain in the butt. You can't see everything. And that's the wrong one. So let's pull up the right one. Okay. Some relief. You can actually use a. This is why I use this grid when I'm doing these. So we'll go back here. 7, 8. 7, 8, good. And this one's going to be 9, 10. Keyframe. And we just keep going down. So if I want 11, I'm going to go 3, 6. And that's the idea. You just keep on doing this until you get to the end of 30 of these things. Now again, you could have used a driver and used it to frames if you're going to use this in Blender only. But since this is going into Verge, one of the ways you do that is through keyframing, and that will be used as a playhead animation that we'll show later on. It's a play animation puzzle. So these values are directly accessible for that sort of animation playback. So I'm just going to keep on going through here, making sure to get the right column value, setting the keyframes, make sure I'm at 21. So next one's 22, 23, 24 is the next row. We only have 29 of these things, so we're almost done. Got to be sure to the rows are set. 26, 27, 28, and last one, 29. Okay. So now the other thing you have to do when you're doing this, it should work all well. But one of the things you want to do is grab all of them, go to interpolate mode, and then select them all to constant. So that way when they're in Verge, they actually play back properly. So once you have all these things keyframed, you can go back and change your, or actually you can go at this point and go do a sneak peek, and you can see that the numbers are zipping along because we have it set up to auto playback, so it's flying through the 29 frames. So you can check your plane there that you've got it on. You can call that, let's call these something here so we know what we're doing. Let's see, plane. What am I doing? Sneak peeks, and turn them all off. And now you can see all the files flying through. So plane 1, let's go ahead and change that back to the file that's supposed to be. That's one there. And you can see that's working when I scrub. it's in the scene. You can also see it in Blender. And that will render out perfectly in EV or cycles. But if you go into Verge3D, it's looking something like this, which is what we want. Now this, again, is using the automated run, so it's just looping through those frames, so you don't have any control. So if we open up Verge3D and we go into puzzles, we look at we want to set the camera target so we can actually look at what's going on. We want to then make sure that we're using the right camera. It's just default things that I do. I'm going to create some variables here. I'm going to do a total frames. In this case, set total frames to 29. And then we're going to create another variable. We'll call this variable the grid size, value of n. And in this case, n is going to be 8. And then we need another, I guess we'll add some comments here. Variable, let's see, we need a row count. We'll also need a column count, but let's see, the row count, start at 0, obviously. Row 0 is the first row. Column count is n -1 for the first column. Let's create a variable column count, I think. What am I doing here? Frame count. That works. We can do that first. Stick that comment back up there. Frame count. Let's do it that way. I like that better. And we're always going to start with a frame count of 0. Loops. No, what are we going to do here? We need to, let's assign the material. So set a value. Well, there's no value. You got to set the material first. Find your sprite, counter column value, and then obviously the row value. And 0.5 is not going to help anything because that's really 0. So if I were to column count, make this one row count. That's 0, 0. And if frame count is greater than or equal to less than 29. Less than or equal to 29. In this case, let's not use a number. Let's use a total frames. Column count. We'll increment by frame count by 1. And if we get to over the 29, we will bring it back to 0. So we're looping through the grid itself. So now we need another if statement. So because we got to handle it, do the row marching. So go ahead and set this logic up. Frame about is equal to 0. And it's less than or equal to 7. That's the first row. Let's go add the second row. That's going to be 8 to 15. I'll add another row. Okay, goes up there. The other row is going to be 16 through 23. Last row is going to be 24 through 29. So what happens here? We have to increment across the UVs. So let's see. Set column count. You could do that. Okay, yeah. And row count equals 7. Do something. Okay, so let's see. Set coordinates. Do that. Set coordinates. So when we drop a row, we're going to do a little bit different math. Let's see, give us that frame count minus grid size. I don't think that's going to work if I do the math in my head. Think about that. Duplicating this process a little bit. That's just not going to work. So let's do this again. There we go. So something's not right here, so I gotta figure out the math. So the math isn't right. So it should be frame count minus 2 times the grid size n. That's right. That is just totally wrong. I was screwing up my math. That's 1 for this thing, duplicate over here. Let's make that a 3. That looks more correct. It seems I'm going to put that into a procedure. We're going to call that the set frames. And then we'll throw time. Now you could use every frame. I don't like it because you don't have enough control. So we're just going to do every second. We'll throw in our set frame there. And then we'll take a look at what happens. Let's see what we got here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 24, 25, 26, 27, 28, 29, and it didn't go over. So what the heck happened? So let's see what happened that it didn't go over. Frame count is going incrementing by 1. When I get to total frames is 29. So I get to frame 29, it should go back to 0. Let's see, what the heck? I'm gonna have to retry diagnosing this a little differently because this doesn't make any sense to me. What did I do wrong? It's causing this. So we will. I think the math is right. Frame count, see, that seems to be right. Row counts, right. All the equations seem good there. So what's going on? So let's try a there we go. Let's do a procedure just to start doing diagnostics since nothing's coming to mind right away why this isn't working. We'll go in developer mode. We're using Chrome, so that helps. And let me slide this over so you can see what's going on. It helps when I don't have dual screens up when you're doing this, but I do. There we go. And it's not getting anything. Let's speed this up. Let's see. I'm not getting anything. So it's not getting to the frame count is 0, so it's never resetting to 0. Why the hell is that not resetting to 0? Let's just make sure everything else is working. So, okay, let's stick it there. And we're just going to check to make sure the frame count is working. And it's stuck there. And the frame counts have stopped. So my frame count stopped at 29. They're not going farther. So what the heck? I think I know what the problem is. Total frames is 29, and it should be not an equals, but just less than. So let's see if this zips through it. There it goes. That was it. You can see it's going quickly. All that's working. Let me stop that. Pull out the diagnostic stuff and save that. And that's one way we can do it. Now we'll go back in and we're going to go back to Blender. We're going to change our lovely texture node. We'll open it up. Let's get off this grid and get back to the fire. Go ahead and open that. and then re-export this little goodie. So file export, Verge3D, go to Fire Puzzles, and then we're going to, got to refresh. Da-da-da, and now we have fire. Now it's going, you control the speed, how fast you want that fire flame to go. It looks like it's rip-roaring and going in Verge3D. Okay, so here you'll see all the puzzles that I'll use for animating sprite sheets using non-keyframes, as well as sprite sheets using keyframe value nodes. Pause as you need to take a look at the detail. I've also included the material nodes close up, so hopefully that'll help as well. I appreciate you tuning in today. Thank you for watching, and hope to see you soon.